Amazon Web Services gives you two ways to ingest a stream of events, and they look almost identical. One lets you rewind and reread a full month of data. The other forgets every record the instant it delivers. That single difference changes the entire architecture. Stack lessons here. Let's settle this topic for good. By the end of this video, you'll know exactly when to reach for Kinesis Data Streams versus Amazon Data Firehose, and how Glue and Athena turn raw S3 data into cheap, fast SQL queries. This is the serverless analytics stack, and one keyword usually decides the whole answer. Let's pin down 4 terms you'll hear throughout this video. We covered Kinesis Data Streams back in episode 14, so that one's already in your toolkit. Amazon Data Firehose is fully managed delivery of streaming data to a destination with no replay. A shard is the throughput unit inside a stream, giving 1 megabyte per second in and 2 out. The Amazon Web Services Glue data catalog is a central metadata store. It holds schemas, not data. And Amazon Athena runs standard SQL directly on files in S3. Here's Megacorp's problem. Their public website throws off clickstream events every second, and their procurement systems fire off purchase order events just as fast. They need to ingest all of that, transform it into something queryable, and then actually run reports on it. And the mandate from above is clear: no servers. Nobody wants to patch a fleet or size a cluster just to answer a question. Amazon Web Services has a serverless stack built for exactly this shape of work: ingest, store, catalog, and transform, then query. The whole pipeline runs with 0 boxes for you to manage. Here's the full flow, left to right. Your streaming sources on the far left push events into the Kinesis ingest layer. From there, the data lands in an S3 data lake, which becomes the durable home for everything. Then Glue steps in to catalog the schema and transform the raw files into an optimized format. And finally, Athena queries that data in place with SQL. 4 managed services, and not one server between them. Let's walk through each piece, starting with ingestion. First up is Kinesis Data Streams. Think of it as a durable, real-time pipe with 3 defining traits. The data arrives in sub-second time, multiple applications can each read the whole stream independently, and you can rewind and replay history. Hold on to those 3 traits. They're what separates streams from everything else in this video. Picture a factory conveyor belt with a recording camera running above it. Several quality inspectors stand along that belt, and each one watches independently. One inspector looking closely never slows down another. That's the multiple consumer idea. The camera keeps footage for up to a year, so anyone can rewind and rewatch what came through earlier. That's replay, and each lane of the belt keeps items in the exact order they arrived. That's per shard ordering. Every one of those properties maps directly to a Kinesis feature, so let's make them concrete. A stream is divided into shards, and the shard is your throughput unit. Each one gives you 1 megabyte per second of writes and 2 megabytes per second of reads. Records that share a partition key always land on the same shard, and within that shard, they stay in arrival order. That's the key nuance. Ordering is per shard, not global. To scale total throughput, you add shards, and you get 2 capacity modes: provisioned, where you pay per shard, or on demand, where Amazon Web Services scales the shards for you based on traffic. On demand exists precisely so you don't have to do capacity planning for a spiky workload. How fast is real time here? The Kinesis Data Streams developer guide puts it plainly. The delay between putting a record into the stream and being able to retrieve it is typically less than 1 second. When a scenario demands sub-second delivery from a real-time feed, Streams is the answer. Firehose and other services don't meet that bar. Now the feature that truly sets Streams apart: retention and replay. By default, records stick around for 24 hours. but you can extend that all the way to 365 days. And here's the important part. Records are immutable. You cannot delete one before it expires. That's what makes replay possible. According to Amazon Web Services, that long retention window enables reprocessing old data for things like algorithm backtesting, data store backfills, and auditing. And notice what this is not. It isn't restoring from a backup. You're rereading the real-time stream just with your cursor moved back in time. The other signature feature is multiple independent consumers. The docs say it directly. Multiple Kinesis Data Streams applications can consume data from a stream, so that actions like archiving and processing take place concurrently and independently. Picture a bank streaming payments. One consumer scores fraud in real time, another feeds a live dashboard, and a third archives for compliance, all reading the same stream at once without stepping on each other. When a scenario needs several separate apps reading the same feed, that's a stream signal. There's one more feature worth knowing: enhanced fanout. By default, all your standard consumers share a shard's 2 megabytes per second of read bandwidth, so if you have many of them, they compete. Enhanced fanout gives each registered consumer its own dedicated 2 megabytes per second per shard, pushed over HTTP2 at roughly 70 milliseconds of latency. Here's the distinction people miss. Enhanced fanout solves throughput isolation between consumers. It does not add replay. Replay comes from the retention window. These are two completely different things. Now the other side of the coin. Amazon Data Firehose. Where Streams is a pipe you actively read from, Firehose is a managed delivery service. You point it at a destination, and it handles the rest. No consumer code, no shards to manage. But that convenience comes with one hard limitation. And it's the thing to burn into memory. There is no replay. The developer guide gives us the exact definition. Amazon Data Firehose is a fully managed service for delivering streaming data to destinations such as S3, Redshift, and OpenSearch. And, quote, you don't need to write applications or manage resources. That last phrase is the exam trigger. Whenever a scenario asks to load streaming data to a destination with the least operational overhead, that sentence is describing Firehose. Think of Firehose as a postal sorting machine with one pre-addressed label. You drop packages in one end, the machine bundles them up on a timer and ships them to your single destination, S3, Redshift, OpenSearch, Splunk, or Snowflake. That timer is the buffer interval. For the S3 destination, the valid range is 60 to 900 seconds, with a default of 300. Firehose added a zero buffering option in late 2023, but that applies to application destinations like OpenSearch, Redshift, and HTTP endpoints, not the S3 backup destination, which still enforces that 60-second floor. Either way, Firehose is near real-time, not sub-second by design. And here's the kicker. Once the truck leaves, you cannot call the sorting machine and ask it to redeliver today's mail. That's the no replay constraint, made physical. One quick note to save you confusion. On February 9th, 2024, this service was renamed from Amazon Kinesis Data Firehose to just Amazon Data Firehose. And Amazon Web Services was explicit that there are no other changes, including service endpoints, APIs, the Amazon Web Services CLI, and the IAM access policies. So if an exam question still says Kinesis Data Firehose, don't overthink it. It's the same service, same behavior, just a shorter name. Let's take a breath and lock in what we have. Streams is ordered, replayable, handles multiple independent consumers, and runs sub-seconds, but you write the consumer code. Firehose is managed delivery to one destination, near real-time, with no replay and no code to write. From your point of view, both are serverless. You never patch a box either way. Now let's get to the decision that this whole topic hinges on. Here's the side-by-side. On the left, Kinesis Data Streams gives you sub-second latency, replay through a retention window of up to a year, multiple independent consumers, and custom processing with Lambda, the Kinesis client library, or Apache Flink, but you own the shards. On the right, Amazon Data Firehose gives you near real-time delivery with a configurable buffer, 60 to 900 seconds for the S3 destination, defaulting to 300, a single managed destination, optional built-in transformation, and zero shard management. Note that the zero buffering feature added in late 2023 applies to application destinations like OpenSearch and Redshift, not to S3, which keeps it 60-second minimum. Either way, no replay. Once it's delivered, it's forgotten. The trade is control and replayability versus pure hands-off simplicity. If you remember one mental model, make it this one. Pull versus push. With streams, your consumers pull data at their own pace, which is exactly why they can control their position and replay history. With Firehose, the service pushes data to a destination on a schedule, and once it's delivered, Firehose is done with it. That single architectural difference, who's in control of reading, explains almost every feature gap between the two. So how do you decide under pressure? Ask 3 scenarios in order. First, do you need to replay historical data? If yes, it's streams, full stop. If no, ask the second question, do you need multiple independent consumers reading the same feed? If yes, again it's streams. And only if the answer to both is no, you just need managed delivery to a destination like S3 or Redshift with minimal effort, do you land on Amazon Data Firehose. Replay or multiple consumers pulls you to streams. Everything else is Firehose. Now, don't fall into thinking it's always one or the other. These two chain together. A Firehose delivery stream can consume directly from a Kinesis data stream, which means one stream can feed your real-time consumers and hand a copy to Firehose for managed S3 delivery at the same time. Megacorp uses exactly this split. Their procurement events go into streams, where one consumer runs real-time alerting and another archives for compliance with full replay. Meanwhile, their website clickstream goes straight to Firehose, which drops it into S3 every 60 seconds with no code at all. Once the data has landed in S3, we need to make sense of it. That's where Amazon Web Services Glue comes in. The official definition is worth hearing. Amazon Web Services Glue is a serverless data integration service that makes it easy for analytics users to discover, prepare, move, and integrate data from multiple sources. Notice the key words there, serverless and discover. Glue does 2 big jobs, so let's break them apart. Think of Glue as a professional librarian. You handed a messy pile of raw handwritten index cards. That's your CSV files. The librarian types them all up into a clean, searchable, compressed format. That's Parquet. And then it updates the library's card catalog so everyone in the building knows exactly where each record lives and what columns it has. That catalog is the shared metadata layer, and 3 different query engines all read from it: Athena, Redshift Spectrum, and EMR, which is Amazon Web Services' managed Hadoop and Spark platform. One catalog, many readers. Let's make the catalog concrete. The Glue Data Catalog is a centralized metadata store. It holds table schemas, column names and types, and pointers to where the data sits in S3. And this is the part to nail down. It stores metadata, not data. The actual files never leave S3. So how does the catalog get populated? Glue crawlers do it. A crawler scans your S3 data, infers the schema automatically, and writes the table definitions. No manual schema definitions to handwrite. And that one catalog is shared across Athena, Redshift Spectrum, and EMR. So a single crawler run serves all 3. Now, here's why Glue's other job, the transformation, actually earns its keep. Take 100 gigabytes of raw CSV logs. Run a Glue ETL job to convert them to Parquet with snappy compression, and that same data shrinks to about 18 gigabytes. But the real win is at query time. Because Parquet is columnar, a query touching just 3 columns on a wide table reads only those columns and skips the rest entirely. Amazon Web Services documentation states that converting to columnar Parquet can cut Athena query costs by 30 to 90%, depending on how many columns your queries actually touch. The narrower your query relative to the table width, the closer you get to that upper end of the range. One distractor to clear up: Glue versus EMR. Both run Apache Spark under the hood, so they look similar. But Glue is fully serverless, no cluster to manage, and Amazon Web Services auto-scales the workers for you. Its keyword is Serverless ETL, and it uses job bookmarks to track what's already been processed so it doesn't redo work. EMR, on the other hand, is a managed Hadoop and Spark cluster where you get deep configuration and tuning control, but you size and manage the nodes. So the queue is simple. Serverless ETL means Glue, while managed Hadoop or Spark cluster means EMR. Let's check where we are. Kinesis handles ingestion, streams when you need replay or multiple consumers, Firehose for hands-off managed delivery. The data lands in S3, which is always the data store in this architecture. Glue then catalogs the schema and transforms raw formats into columnar Parquet. That leaves one final piece, actually querying the data in place with SQL, and that's Athena. Amazon Athena is the query layer, and the docs sum it up perfectly. Athena is an interactive query service that makes it easy to analyze data directly in S3 using standard SQL. And it's serverless, so there's no infrastructure to set up or manage, and you pay only for the queries you run. 3 ideas in one sentence. Standard SQL, data stays in S3, and paper query. That's the whole service. If Glue is the librarian who organizes the books, Athena is the reference librarian who answers your questions about them. You ask in SQL, and the books never leave the shelf. The data stays right in S3. Nothing is moved or copied into a separate database. Athena flips through only the relevant chapters, which is exactly what columnar Parquet enables. And you pay only for the pages actually read, $5 per terabyte scanned. To know the schema, Athena reads straight from the Glue data catalog. That pairing, Glue for metadata and Athena for queries, is the standard serverless analytics answer. Since you pay per byte scanned, cost control is really about scanning less. There are 3 levers. First, partition your S3 data by data region so Athena skips non-matching prefixes entirely and never even looks at them. Second, convert to columnar Parquet, which cuts the data scan by 30 to 90% according to Amazon Web Services documentation, and on very narrow queries against wide tables, savings can push even higher. Third, compress with Snappy or gzip. But there's a caveat worth remembering: don't over-partition. If you split into thousands of tiny partitions, Athena's work just to list them becomes the bottleneck. A good rule of thumb is at least 128 megabytes of data per partition. Here's the classic wrong answer to watch for. A scenario describes data already sitting in S3, an analyst running ad hoc exploratory queries, and the tempting distractor is Amazon Redshift. But Redshift means provisioning and managing a cluster of nodes, which is overhead and ongoing costs you don't need. When the data's already in S3 and the queries are ad hoc, Athena wins. It's serverless and charges only for what it scans. Redshift earns its place for heavy, repeated analytic workloads, not for a quick look at files in a bucket. Let's watch Megacorp's whole pipeline run end to end. Procurement events flow into Kinesis Data Streams, sub-second and replayable, where one consumer does real-time alerting with Lambda and another handles compliance archival. Separately, website clickstream goes to Amazon Data Firehose, which delivers it to S3 on a 60-second buffer with no code. Overnight, a Glue crawler catalogs the schema, and a Glue ETL job converts the raw files to Parquet partition by date. The next morning, the analytics team runs standard Athena SQL against it, from ingestion to query, not a single server managed. Before the quiz, let's lock in a few distinctions that are easy to blur. Firehose has no replay capability. If you need to rewind and reread data, only Kinesis Data Streams supports that. Firehose is near real-time by design, with a buffer that can go as low as 0 seconds, but it is not a substitute for streams when sub-second latency is a requirement. Glue and Athena store no data of their own. S3 is always the data store in this stack. And Kinesis ordering is per shard, not global, so strict global ordering requires a single shard stream. One more. Enhanced fan-out is about throughput isolation, not replay. The two are unrelated. Here's the cheat sheet to carry into the exam. Real-time plus replay plus multiple consumers points to Kinesis Data Streams. Load streaming data to S3 or Redshift with the least management and no replay points to Firehose. Serverless ETL, a data catalog, or CSV to Parquet conversion points to Amazon Web Services Glue. And serverless SQL on S3 or querying data without infrastructure points to Amazon Athena. Match the keyword to the service, and these questions become fast. Now let's put it to the test with a quick 5-question quiz. Question 1. A fintech team streams payment events and needs 3 independent applications: fraud scoring, a live dashboard, and compliance archival, all reading the same data. 6 months later, they need to replay 30 days of past events to backtest a new fraud model. Which service fits? Is it A, Amazon Data Firehose delivering to S3, B, an Amazon SQS standard queue, C, Kinesis Data Streams with 30-day retention, or D, an Amazon SNS fan-out topic? Pause here if you want more time. This one is C. Kinesis Data Streams is the only option that gives you both multiple independent consumers reading the full stream and replay through its retention window. Firehose delivers to a single destination and has no replay, so it can't backtest against history. Question 2. A web analytics team needs to load raw clickstream events into an S3 data lake for later batch analysis. They want the least operational overhead, no consumer code, no shards to manage, and they do not need replay. Which service should they choose? A, Kinesis Data Streams with enhanced fan-out. B, Amazon EMR with a Spark streaming job. C, Amazon Web Services Glue, streaming, ETL. Or D, Amazon Data Firehose. Lock in your answer before I give it away. The right call here is D, Amazon Data Firehose. Least operational overhead, load streaming data to S3, and no replay. That phrasing points straight at Firehose. It delivers to a destination with 0 consumer code and no shards to manage. Question 3. An analytics team has 3 years of logs sitting in S3 as CSV. They need to run occasional ad hoc SQL queries over that data as cheaply as possible, with no infrastructure to provision. What is the best choice? A, load the data into an Amazon Redshift cluster and query it there. B, Amazon Athena querying the data directly in S3. C, spin up an EMR cluster and run Spark SQL. Or D, import the CSV into an RDS post-SQL instance. Think about which constraint matters most here. It has to be B. And here's why. Data already in S3, ad hoc queries, and no infrastructure to provision all point to Athena. It runs serverless SQL right on S3 and charges only for data scanned. Redshift and EMR would both make you stand up and manage a cluster. That's the trap. Question 4. A team wants their Athena queries over S3 data to run faster and cost less. The data is stored as uncompressed CSV. Which single change delivers the largest reduction in data scanned per query? A. Convert the CSV to columnar Parquet via a Glue ETL job. B. Enable enhanced fan-out on the ingestion stream. C. Move the bucket to a different Amazon Web Services region. Or D. Increase the Firehose buffer interval to 900 seconds. Got your pick? Let's see. If you said A, well done. Converting to columnar Parquet lets Athena read only the columns a query actually needs, cutting scanned data by 85 to 99%. Enhanced fan-out, the region, and the Firehose buffer have nothing to do with how much data an Athena query scans. Question 5. In a serverless analytics architecture using Glue and Athena over data in S3, which statement is correct about where the actual data lives? A. The Glue data catalog stores the data itself, and Athena copies it into query. B. Athena loads the S3 data into its own managed database before querying. C. Both Glue and Athena store only metadata in queries. S3 remains the data store. Or D. The data must be duplicated into Redshift for Glue to catalog it. Run the decision rule from earlier before you answer. The answer is C. The Glue data catalog holds metadata only, schemas and S3 locations, and Athena queries the data in place. Neither service stores the actual data. In this whole architecture, S3 is always the data store. And that's data ingestion and analytics. Kinesis, Glue, and Athena, demystified. Subscribe for the rest of the Cloud Architect path so you never lose the thread, and to help YouTube show these wider. Drop a comment with what clicked and what didn't. If there's a certification you'd love me to cover, suggest it below. And tell me how the pacing and style feel for you. Catch you next time.